You're going to need your heat of solution lab with data for the 3 experiments and a calculator. If you don't have data for the experiments, you can ask a neighbor and use their temperatures from their lab and just use the volumes and the masses from the lab procedure. In the data table, make sure that when you're calculating the temperature change, you are subtracting the final temperature at the end of the experiment from the initial temperature. Make sure to notice the positive or negative sign on your calculator when you're doing final minus initial. If you have a negative sign, that means the temperature went down or the experiment felt cold. You can decide if that's endothermic or exothermic. On the opposite end, if your final minus initial temperature is a positive number, that means your temperature went up and it felt hot. So you can decide if it's exothermic or endothermic. For number 1 in procedure part A, in order to determine the heat in joules the water absorbed, you're going to use our old friend Q equals mc delta T of the water. For calculating the heat of the water, you're going to use the volume of the water, which was 45 milliliters. Water is special because its volume is directly equal to its mass. So you can use the mass of water as the volume you poured, 45 grams, times the specific heat, 4.18 joules per gram degree Celsius, times your delta T that you calculated in data table 1. The acid that we used in this lab was a concentration of 3 molar. 3 molar means that there were 3 moles of acid in every 1 liter of water. And so if you write the units as 3 moles per 1 liter, we can convert moles per liter into just moles of the sulfuric acid. So we know that for every 1 liter, it is equal to 1,000 milliliters, but we didn't use 1,000 milliliters, we used 8. So basically I've just set up proportions or a truth table in which liters cancels and we're left with moles per milliliter, and we used 8 milliliters, so now milliliters cancels and we're left with just moles. You can finish calculating this math by multiplying each number in the numerator and dividing by each number in the denominator. You do not need to multiply and divide by the number 1. For calculating number 3, the molar heat of the solution, you're going to take your joules and divide by moles of the acid we used. So you calculated joules in number 1, and you calculated moles in number 2. Now all you have to do is divide, and you will get the answer in joules per mole. This represents the delta H that we've been calculating all along. So now in number 4, you can balance the equation for sulfuric acid dissociating in water, and you can put your answer to number 3 on the correct side of the chemical reaction showing endothermic or exothermic, or you can write the delta H as being positive or negative depending on if this calculation is endothermic or exothermic. In part B, we used ammonium chloride in water. First, you want to calculate the joules the water absorbed from the ammonium chloride by doing Q equals mc delta T of the water. In this case, we used 30 milliliters or 30 grams of water times the specific heat of water, 4.18 joules per gram degree Celsius, times the delta T that you calculated above. In order to determine the moles of ammonium chloride that you used, you're going to need your periodic table. You used 5 grams of ammonium chloride, and the formula is written up above, NH4Cl. So if you set up a truth table starting with the grams of NH4Cl and dividing by the mass of NH4Cl as added up on the periodic table, you will be able to calculate the number of moles of NH4Cl that were used in this experiment. So for number 3, if you take your answer from number 1, the joules absorbed, divided by number 2, the moles you used of ammonium chloride, you'll get an answer of joules per mole, or the molar heat of the solution, which is also what we've been studying and calling delta H. So now that you know the delta H of the chemical reaction that you did in part B, you can write the thermochemical reaction for ammonium chloride dissolving in water. You can either put the delta H as positive or negative next to the chemical reaction after you've balanced it, or you can write the delta H on the correct side of the equation depending on if it's exothermic or endothermic based on your data table. The third and final experiment is a lot like the first, except this time we didn't use water, we used acid. However, in order to make hydrochloric acid, it's mostly dissolved in water. So therefore, you can assume that in this chemical reaction, the hydrochloric acid is exactly equal to water in all of the calculations. So for number 1, finding the Q, or the heat the water absorbed, we're going to use hydrochloric acid 20 grams and the specific heat of water, because hydrochloric acid, in this case, is standing in for water. Use the delta T that you calculated up above in your data table. In order to determine the moles of the hydrochloric acid, since we used a liquid, just like in part A with the sulfuric acid, the chemical concentration of the acid was 1 molar, meaning that there was 1 mole of HCl for every 1 liter. The problem is we didn't use 1 liter of acid. So we need to convert liters to milliliters, and then we need to figure out how many moles were in the 20 milliliters that we used using truth tables or unit conversion. So now you can do this math in number 2. When you find the answer to number 1 in joules, you divide by the answer to number 2 in moles, and you'll get your answer to number 3, the joules per mole, or the delta H molar heat of this chemical reaction. So now you can balance the thermochemical equation in number 4 and place the delta H in the correct location on the product side or the reactant side based on if it's endothermic or exothermic, or you can write the delta H as being a positive or negative number. If you're having trouble with number 4, look back at the bell ringers that we've been doing the last 2 weeks. We've been writing these both ways on all the bell ringers. So take a look back through those so that you can get a handle on how to write the delta H on the left or the right side based on endothermic and exothermic reactions. And that's it. So there's a picture of Maggie looking happy because she's going to finish her post-lab questions, put her name on the lab, and turn it in. Have fun and good luck on the quiz at the end of the period. I'll see you tomorrow.